Hi, welcome to Dave's 10-minute Tech Talks. This particular Tech Talk is on deploying AI. This is from a series of talks that I do. Each is intended to be very short, a video presentation to give business people, business managers, and leaders in organizations an idea or a better understanding of the technologies that they're dealing with. As I said, I'm doing several series around these Tech Talks. This series, right, so I've already done a previous video, which I released on LinkedIn around in my YouTube channel on what is AI. I've done another video around managing the risks associated with artificial intelligence or AI. And then this video is going to be about how do you deploy AI solutions in your organizations and what are some of the key learnings that I've had over the course of the last few years as I've been deploying artificial intelligence into various organizations. So that's the Now, one of the things that I like to start out with when I talk about artificial intelligence is this concept of the known unknowns. This was a term that was made popular by a gentleman by the name of Donald Rumsfeld, who was the former U.S. Secretary of Defense when they went into Iraq. And he said that, and I quote, "There are known knowns. These are the things we know. There are known unknowns. That is to say, these are the things that we know we don't know, but there are also the unknown unknowns. These are the things that we don't know that we don't know." There's lots of people that have made jokes around this and stuff like that, but it's an interesting point to think about. What he was referring to is the way the military thinks about risk, right? And this is actually a fairly well-known methodology. And this whole idea that there's lots of things that we know that we don't know that we need to manage for, right? In the case of artificial intelligence, this is very apropos because there's a lot of things that we still don't understand yet about how do we deploy AI solutions, what's the most effective way of deploying them, how are they going to work, what are the most effective mathematical technologies. This is not like, say, the classic ERP or CRM system, which I personally have been involved in hundreds of deployments around, and I'm sure lots of people who are watching my video have as well, where you know the technology, you understand principally how it works, therefore you can articulate the business requirements around how it's going to do it. It's not going to be fundamentally be changing in terms of your business model. It's fairly predictable. In terms of using artificial intelligence, it's very not predictable in terms of the impact it's going to have on your organization. And there's a lot of known unknowns. For example, is this the right technology? Are you using the right solution, the right vendor for this solution? Does it actually generate new business requirements? Can you solve problems that were never solved before? And in so doing, can you actually generate a whole new set of requirements because you've solved those problems? What is the best business model that's going to support you in terms of using artificial intelligence? Because you're solving problems that have never been solved before, or you're opening up new avenues of, for example, providing products or services, you may end up with completely new business models that need to support those new AI solutions. And what's the best deployment method to suited for that particular solution? What is the best technology? What is the best way of laying it out and deploying it? These are things that are still unknown in terms of AI. You will get lots of systems integrators and vendors come along and tell you that they're experts and they've done it all before, and that they're experts in all forms of AI and they're done so many different deployments before. If they tell you that, it's really not true, in my opinion. Even in experience consultancy, some of the more mature consultancies, in terms of using artificial intelligence, really have only been doing it for maybe 2 or 3 years. So their experience is still fairly limited. And if you get down to specific use cases in specific industries, it's even more limited. So this is still very much an experimental form of technology. And then the biggest issue that you get with what's the known unknown around these technologies, and particularly artificial intelligence, is ultimately how long will the project take and when will it generate value. So again, there's a lot of these known unknowns that you have to deal with when dealing with artificial intelligence. So how do you handle these? So knowing that there's a lot of known unknowns and also there's a lot of unknown unknowns, how do you manage these? So in my opinion, based on my experience, there's a number of what I would call key ingredients for a good AI deployment. I'll cover them over at a high level here, and I'll go into each one in detail, and then I'll summarize at the end. One of the first key ones is to understand the impact of technology on your business model. How is your business model going to change? How is this going to be transformational in terms of the products and services that you can provide to your customers? Second, how do you adopt a hypothesis-driven approach? Recognizing that you don't know a lot of these known unknowns, how do you actually experiment in a purposeful way, in a structured way, to see how these technologies will impact your business and how they will change things? Recognizing that it's really hard to understand the requirements for these technologies up front, and really you may have a problem you're trying to solve, but you don't know the details of specifically of how you're going to solve it or how it's going to work. Then how do you adopt a agile delivery method, gathering information along the way and adjusting your MVP? Then just things like good project management. I think this applies to any kind of technology that you put in. You add all these things together, these sort of 4 key ingredients, and you, in my opinion, end up with a higher chance of success in terms of your AI projects. So the relationship between technology, business models, and value. So one of the things I'm going to throw out there is this idea that um, a technology does not generate value. A technology enables a business model that generates value. What is a business model? A business model is how you go about achieving or running a business. A business strategy is usually the what. Like, for example, I'm going to sell children's clothing. The how is how I'm going to do it. Well, I'm going to sell it online using a particular distribution model, right? Um, the term has been around. The concept of business model has been around for quite a few years. It was made popular specifically by some work done by a gentleman called Elsterwalder, who, as part of his PhD thesis, developed a new methodology for mapping out business models called the business model canvas. It has been demonstrated through a lot of research, as I said, that these new technologies enable the new development of business models, and it's the business model that generates value. Examples of this prior to the internet would include things like the steam engine, which enabled completely new business models in terms of mass production. And there's all kinds of other examples, electric light. These are all technologies that enable new business models, and therefore people to change fundamentally how they went about doing business. Things that enable new one of the things that business models do, or technology enables with regards to new business models, is changing transaction costs, enabling new products and services, and making it possible to reach new customers and markets. The impact of a firm's business model on its valuation has also been demonstrated, and it can be very dramatic. For example, people could argue that one of the reasons why Snapchat IPO'd for $28 billion when they had almost no profit and very little revenue was because of the fact that they had a really, really unique business model. A recent example, and as I said, that's an example of Snapchat, is also thus it's reasonable to conclude that new innovative technologies generate new business models. So new technology like AI, new business model, increased company value, emphasizing the point that you really have to have a think about your business model when you're deploying a new technology, how it's going to impact that. As I said, one of the tools and techniques that you can use to develop your business models is the business model canvas. There are a number of different methodologies out there. The one by Elsterwalder, the business model canvas, is just one of the more well-known methodologies, but there are quite a few tools and techniques you can use out there right now to develop. The hypothesis-driven approach. This is the idea that, and this was made popular in terms of new business startups, or new businesses are trying to, or people are trying to start up a new business with imperfect information. So how do they go about doing that? What I would say to you now is that people more and more in terms of large corporates are using the hypothesis-driven approach when it comes to new technologies and new business units, because even though they're a large corporate and have probably better access to information than a new startup would, it's still imperfect. And it's done with a view that speed matters, the time to market is key. You basically want to try something, test it. If it works, then invest more time into it. Um, and this whole idea that, if you test something, you can then evaluate to see what impacts it may have on your business model and how it would work. The hypothesis-driven approach also recognizes a couple of key issues with regards to how do you make decisions, and that is that people tend to be overly optimistic. They tend to feel that if they plan a lot, that's actually going to solve all their problems, which is not necessarily the case. They tend to something called confirmation bias, where they tend to seek facts and figures that support their original decision, even if it might be the wrong decision. And this also issue of sunk cost bias, where economics tells you that even though you spent a lot of money on something, you should only really look at the money you're just going to spend going forward and the benefits you're going to generate going forward to take a decision. A lot of people don't. So what is the hypothesis-driven approach? What are the key steps in the hypothesis-driven approach? Well, the first thing is you want to establish your sort of designer vision. What is this solution going to try to achieve? What do you want to try to achieve in terms of solving a problem, right? Then you're going to determine your key assumptions around that. What's the technology? Assumptions might include what technology you're going to use, what's the business process, what's the business model, how you're going to approach it, how you're going to deploy it. Then you're going to prioritize those assumptions, say what are the more important ones that are more fundamental in terms of the success of your project or your idea. You're going to pick those top ones that are more fundamental, and then what you're going to do is you're going to build a minimum viable product or solution, or possibly use some other marketing testing approach to build and then test those assumptions that you've come up with in terms of your solution. And then you're going to take a look at how that worked. You're going to either persevere, in other words, say, look at this worked, the current solution works, and I'm just going to keep using it. Or you're going to pivot, which means you're going to change the style of your solution, change your business model, change your technology, or you're going to say this is never going to work, and you're just going to kill the system off. Um, there are a number of tools and tactics that people use when they're adopting a hypothesis-driven approach. One of them is to create a minimum viable product, as I said, or a series of minimum viable products to release to the market. Also, you can use what we refer to as pilots or proof of concepts. So you're not actually building a production system. What you're doing is you're building something out and you're demonstrating to people to see if it works or if they like that solution. And then people also do things like smoke tests and other consumer analysis techniques. A smoke test is where essentially you build a website and you see whether you make an offer on the website, but then when people go to click on the offer, you say, oh, it's coming soon, and you drop their details. That's just a way of gauging customer. Once you've decided on the technology or the solution you're going to do, you're going to solve with artificial intelligence. Once you've decided what your MVP is going to look like, when you go to build a minimum viable product, you want to do that in what they refer to as an agile fashion. What is agile? It's a software development technique that's been around for a few years. Basically, where it accepts the fact that you can't have a clear view of requirements up front. So what it does is it advocates adaptive planning and evolutionary development, where you essentially spend more and more time ongoing as you develop the solution with the users of the solution to get their feedback as you go. It encourages rapid development and flexible response to change. It was popularized when they released something called the Manifesto for Agile Software Development. You can go and look at this online. The Agile Manifesto, it has sort of 12 key points. It talks about what an Agile software development process is, including the concepts of Scrum and Kanban. This particular What's the difference between waterfall and agile? So traditional, like if you guys have been deploying ERP systems or CRM systems or other kinds of business systems, more often than not, people have used a waterfall approach where they sit down, they figure out all the requirements up front, they design a solution, they build it, they test it to those requirements, and then they deploy it. What Agile says is that we don't really have a complete view of our requirements up front. So what we'll do is build the solution, get some feedback on it, build some more, get some feedback on it, build some more, get some feedback on it. And what they do is you build the solution, what they refer to as sprints. So you're constantly getting feedback from the users as you're building the solution. The other issue that you have to be considerate of when you're deploying any kind of project, not just AI projects, is this issue of the project management triangle. You can go and search this online. There's lots of articles written about this. Basically, what people say is that when you're deploying a project, you have to recognize that there's a trade-off between cost, time, and quality of the solution. So if you decided that you're going to use AI in your organization and you want to deploy it in a specific area, you've come up with a concept of an MVP to test whether the AI solution is going to work and the business model is going to work around that. You may, in terms of the size of that MVP, have a trade-off in terms of, well, I'm going to build it smaller because I want to get to market quicker, save cost, but then the quality of the scope of the solution will be reduced. So this is the trade-offs you have to think about. So just something to think. The other issue is when you're talking about deploying your AI solution, you really have to be worried about the actual quality of your solution. And there's a number of things you have to think about. The first thing is that the results of any AI toolset that you make should be reviewed by the people who are actually involved in the process. You do not come up with a set of specifications, give it to a data science, go away and have them come back, and then just deploy it. You actually have to validate it. People have to test it. They have to make sure that the decisions that this artificial intelligence tool is making actually make sense. The other challenge that you have to worry about, and there's a lot of ways you can test for this, is this issue of unintentional bias, particularly in the form of AI referred to as supervised learning or supervised machine learning, where human beings are actually teaching the AI how to behave. If there's bias in terms of the data that the human being has selected for that AI to use or to train that AI, then there'll be bias in the decisions that the AI makes or the artificial intelligence tool makes. So you need to make sure that you test for that unintentional bias and that you have the right data set. The other thing that you need to do with your AI models is cross-validate them. So don't just, again, people have this thing where they send the data scientists off, they build them all, they come back and say, see, it works perfectly. They don't actually cross-validate to see if the actual model works in a number of different circumstances with different data sets. Because depending on your data set, your AI may actually have good results for one data set, but not for another one. So you need to cross-validate it across a number of different data sets. And my view is AIs are, they're tools. They're like, I always think of an artificial intelligence solution as like a child. the child is young, you teach it, you let it do things, you watch it as it doing things to make sure it doesn't hurt itself and doesn't do the wrong thing. As it grows and you become more trusting and you believe they can make the right decisions, and you spend time less managing it. It's the same with AI. Is you have to have this feedback loop where you build a solution, put it into place, and then you continue to tune it to get it, make sure it's accurate, and then make sure it's getting better. And then you should also periodic check it to make sure that it's not coming to the wrong conclusions. Because if you watch my video in terms of risks associated with AI, you'd realize that, for example, one of the challenges with AI, if you build an AI tool that's based on data in your system and someone's changed the definition of the data in your system or changed some of the upstream technologies that provide data to your artificial intelligence tool, it'll start making the wrong decisions because it's got the wrong data and it doesn't know any better. So you need to periodically check it to make sure that that's not. So these are sort of the four core, these are the key things that I said to you that lead to a good AI deployment. Understand the impact of the technology on your business model, adopt a hypothesis-driven approach in terms of using an MVP when deploying your AI solution, adopt an agile delivery mode when building that MVP so you're constantly getting feedback, and just applying good project management, which applies to any kind of technology project. So, if you're looking at a typical deployment, when I've done deployments in the past around AI solutions, it would kind of go like this, where you'd identify the problem, you talk to the business or the organization, they'd say, my issue is related to this. You'd say, okay, you complete a feasibility assessment, so you'd spend a little time with them to understand, do you have the right data to build an AI tool set to fix this? Are they supportive of the process? Are they willing to participate with you in terms of development of that process? You want to spend some time understanding your assumptions and what you're going to test when you build your minimum viable product solution. Then you'd go and deploy that minimum viable product solution. You did use that agile delivery methodology, as I said. Once you deployed it, then you'd step back and say, okay, did I actually achieve what I set out to achieve? Do I need to change the technology or the solution in terms of how I'm deploying the AI? Do I need to change my business model? Do I need to change my business processes? Right? And then you move to a production deployment. So this is the typical process that I would go through. And given the number of known unknowns, as I said, it's highly likely they will take several tries or several MVPs before you get to the ideal solution with your AI solution development. Now, it sounds like this is, it goes into fairly difficult, this means that AI deployments can be fairly difficult. This is true. That being said, the benefits they generate can be massive. In my experience, the fundamental changes that it can make to organizations in terms of cost savings, improving customer service, well justify the investment in terms of this approach, this novel approach in terms of deploying AI solutions. As I said, if you have any questions, you can send me an email at david.goat@sydney.edu.au, or if you want, you can find me on LinkedIn and send me a question that way. Hopefully you found my presentation useful, and hopefully you listen to, I'll have, my next series is going to be, in terms of Tech Talks, will be on blockchain solutions, and hopefully you'll listen in for those as well. Thank you.